The truth is out there, and so is the future. Welcome to Gen AI Cafe, where we explore the strange, the powerful, and the unexplained world of generative AI. With your host Nico Peters, and in each episode, we'll uncover how artificial intelligence is reshaping our reality, pushing the boundaries of creativity, and challenging everything we know. Are we witnessing the dawn of a new era, or playing with forces we can't control? Stay tuned and prepare yourself to venture beyond the edge of innovation, where technology meets the unknown.
Generative AI, a rapidly advancing field in artificial intelligence, allows machines to generate content that mimics human creation. Unlike traditional AI that identifies patterns, generative AI focuses on producing new data. This by focuses on prodigies, music, and even videos has significantly impacted various industries. In essence, generative AI employs models that learn from data to produce novel outputs. These models leverage deep learning techniques to understand and replicate the intricacies within the data they are trained on. Such capabilities have led to innovations in fields like art, entertainment, and education. Moreover, the significance of generative AI extends beyond content creation. In healthcare, for instance, these models assist in drug discovery by simulating molecular structures and predicting chemical reactions. In fashion, they're used to design clothing, offering personalized solutions based on consumer taste. Generative AI also plays a crucial role in enhancing human creativity. Artists and designers harness these technologies to explore new styles and concepts, expanding the boundaries of their creative work. By automating routine tasks, it frees up human creators to focus on more complex, innovative endeavors. As we delve into the evolution of generative AI, it's essential to recognize its transformative impact. However, this journey from conceptualization to practical application has been marked by continuous refinement and breakthroughs. Understanding this evolution provides context for the advanced technologies we see today. With this foundational understanding of what generative AI entails and its significance, the next logical step is to explore the early algorithms and models that laid the groundwork for the sophisticated technologies we have now. Let's look into how it all began. As we delve into the early stages of generative AI, we find ourselves captivated by the foundational algorithms and models that paved the way for modern generative technologies. Understanding these early systems allows us to appreciate the advancements and synthesize the knowledge that has led us to today's cutting-edge AI tools. Early models of generative AI primarily focused on ruler-based systems and simple models often limited in scope and capability. These rudimentary systems relied heavily on predefined rules and lacked the sophistication to create truly innovative outputs. One of the initial breakthroughs was the Markov chain. This stochastic model processes data by predicting the probability of a sequence of possible future outcomes based on past states. Widely used in text generation, it was instrumental in understanding and simulating submittal data patterns. Another foundational component was the hidden Markov model lemma. Introduced the ability to handle more complex data by modeling hidden states, making it a significant step forward in the field. This model found prominent use in various applications, including speech recognition. The birth of neural network provided a different paradigm shift. Despite their simplicity, early neural networks laid the groundwork for subsequent breakthroughs. The perceptron, one of the earliest neural network models, paved the way for understanding pattern recognition. The evolution continued with multi-layer perceptrons and backpropagation algorithms. These advancements allowed for the development of deeper networks, offering more complex pattern recognition than ever before. This era marked the beginning of utilizing deep structures to encourage model learning and accuracy, albeit primitive, compared to modern standards. Each of these early models was instrumental in setting the scene for more sophisticated systems. They not only provided theoretical foundation, but also motivated further innovation, leading to the next generation of AI models. As the field of artificial intelligence continued to evolve, researchers sought more robust and versatile techniques for generating synthetic data. Enter generative adversarial networks, a GAN, a groundbreaking development in the realm of deep learning. Introduced in 2014 by Ian Goodfellow and his colleagues, GANs brought out a new paradigm by ingeniously framing the generative process as a game between two neural networks, the generator and the discriminator. The generator's role is to create data that mimics real-world examples, whether images, music, or other forms of data, while the discriminator evaluates these outputs, striving to distinguish between actual data and the generator's creations. Through this adversarial process, both networks become increasingly proficient, propelling the generator's outputs to reach impressive levels of realism, GANs, versatility. GANs can be applied across various domains such as image generation, video prediction, and even 3D modeling. Quality of results. The iterative feedback loop between the generator and discriminator leads to high-quality synthetic data. Creative potential. GANs have been used to generate artworks, music, and more, sparking creativity across industries. While the introduction of GANs marked a significant leap forward, their complexity also introduced challenges such as issues of training stability and mode collapse, where the generator produces limited variations of outputs. Nonetheless, the initial impact of GANs was profound, setting the stage for a proliferation of applications and variations that would follow. The emergence of GANs laid the foundations for innovations that transformed various sectors, gradually influencing how media is created, perceived, and consumed. Moving forward, we can witness the strides made in media industries through GAN-driven innovations. As we delve into the world of GANs, it's clear that these models have redefined what's possible within the realm of media. The influence of generative adversarial networks extends far beyond the traditional boundaries of computer-generated imagery, impacting everything from photography to audio. Visual content creation. GANs have enabled stunning breakthroughs in image generation, allowing creators to synthesize high-resolution visuals that once thought impossible. Whether it's creating realistic human faces, landscapes, or transforming sketches into lifelike art, the possibilities are endless. Deepfakes in animation, while controversial, deepfake technology powered by GAN demonstrates how media can be manipulated to create convincing simulations of people and voices. It's a tool that opens discussions around ethics in digital media, but also offers innovative possibilities in filmmaking and entertainment. Audio innovations. Beyond visuals, GANs are making strides in the auditory domain. They can generate realistic sounds and music compositions, pushing the boundaries of sound design and media production. These capabilities allow sound engineers to craft entire soundscapes that redefine the auditory experience beyond traditional media. GANs have also broadened the scope of interactive media and gaming. Artists can generate expansive and immersive virtual worlds efficiently, making video games and virtual reality experiences more dynamic than ever. In essence, GANs serve as a catalyst for media innovation, offering tools that enable creators to explore new realms of imagination and possibility. As we transition to the next technological frontier, it's intriguing to see how these advancements will interplay with other AI models to further enrich media content. Following the advances driven by GANs, the AI community experienced another surge of development with the introduction and evolution of transformer models. At the heart of these models lies the attention mechanism, which enables the AI to focus on different parts of the input data more effectively. This innovation tackles some of the previous limitations faced by traditional recurrent neural networks, notably in processing long-range dependencies in data sequences. The arrival of the transformer architecture sparked a transformation in generative AI, particularly with models like BERT, GPT, and T5 leading the charge. These models harness the power of the attention mechanism, allowing for superior handling of context, resulting in more coherent and contextually aware outputs in tasks such as language translation, text summarization, and question answering. Transformers introduce several attractive attributes to the AI landscape, such as parallelization during training, which drastically improved efficiency. This capacity for parallel processing was critical in scaling up models and datasets, paving the way for future breakthroughs. Ultimately, The breakthrough transformer models were pivotal in advancing the state of the art in AI, inspiring a slew of research directions and applications. This success can be attributed to their flexible architecture, which has been adapted to accommodate various tasks beyond natural language processing, including image and speech processing. As the technology continued to evolve, the capabilities of these models expanded, making them essential tools in the repertoire of AI researchers and developers. With a stage set by transformers, this evolution ushered in the era of large-scale models that harness these foundational advances for even more sophisticated applications. Next, we explore how these developments laid the groundwork for the rise of large language models, further revolutionizing the generative AI field. As bias and misinformation, developers and researchers continue to grapple with these hurdles, seeking solutions to make LMAs more efficient and equitable. As we move forward, the implications of relying on such powerful models spark discussions of the boundaries of automation and human responsibility in AI advancements. This brings us to the pivotal figures and visionaries driving the evolution of generative AI, who continue to shape and challenge the potential of these burgeoning technologies. The trajectory of generative AI has been significantly shaped by the vision and dedication of key figures who have pushed the boundaries of what machines can create. This section shines a light on some of these trailblazers whose pioneering efforts have laid the groundwork for today's innovation. One standout figure is Geoffrey Hinton, often referred to as the godfather of deep learning. His research on neural networks in the 1980s paved the way for the developments we see today in generative models, especially with breakthroughs in unsupervised learning. Then there's Ian Goodfellow, the mind behind generative adversarial networks GANs. His 2040 paper introduced a framework where two neural networks contest to each other in a game, leading to mind-blowing advancements in generating realistic imaging. Yoshua Bengio, a major proponent of deep learning, has been pivotal in refining the ideas around autoencoders and their application in generative models. His work continues to influence many modern AI systems. And another one name is Yan LeCun, who introduced convolutional neural networks in Landsat, fundamentally transforming image recognition and classification, technologies that are integral to generative AI today. These visionaries, along with their contemporaries, not only introduced groundbreaking theories and applications, but also cultivated environments that fostered incredible advancements in AI research. As the landscape of generative AI continues to evolve, it's important to acknowledge these pioneers who have set the stage. Next, we will delve into the influential research labs that have been instrumental in driving these innovations forward. As we explore the landscape of generative AI, it's crucial to recognize the influential research labs and institutions that have been at the forefront of these groundbreaking advancements. These hubs have fostered innovation, collaboration, and the dissemination of cutting-edge technology in generative AI. Among such institutions, OpenAI stands out with its commitment to ensuring that general AI benefits all humanity. OpenAI has set benchmarks in generative AI development, with models like GPT profoundly influencing real-world applications. Another game changer is Google Brain, known for pioneering deep learning techniques. This lab has significantly contributed to advancements in natural language processing and image generation, paving the way for more sophisticated AI models. Not to be overlooked, Facebook AI Research AI has been instrumental in advancing AI through open collaboration and sharing resources. Their contributions to generative adversarial networks GANs have opened new frontiers in how machines perceive and generate data. DeepMind, a subsidiary of Alphabet, has been another key player. Renowned for its work in reinforcement learning and neural networks, DeepMind's research extends into healthcare and scientific discovery, showcasing AI's potential beyond conventional boundaries. Alongside these tech giants, academic institutions like MIT's Computer Science and Artificial Intelligence Laboratory at Yale and Stanford University's AI Lab have been nurturing future AI leaders, continually pushing the envelope with their innovative research and projects. Finally, collaborations between these labs and the broader AI community underscore the importance of synergy in accelerating progress. These collaborative efforts lay the groundwork for the next phase of the global evolution. As we delve into the milestones in generative AI technology, it's essential to appreciate these influential research labs' role in shaping a future where AI serves humanity's best interests. As we delve into the significant milestones in generative AI GenAI technology, it's crucial to highlight the pivotal innovations and breakthroughs that have paved the way for today's advanced systems. Let's take a closer look at some of these pivotal moments that have shaped the evolution of this transformative technology. Introduction of generative adversarial networks. Developed by Ian Goodfellow and his colleagues in 2014, GANs mark a turning point for GenAI by introducing groundbreaking architecture where two neural networks of one generator and one discriminator compete against each other. GANs enabled the creation of realistic synthetic data and images. Advancements in transformer models. The introduction of transformer models, specifically BERT bidirectional encoder representations from transformers introduced by Google in 2018, significantly improved understanding context in natural language processing. This advancement allowed for more sophisticated and nuanced text generation. Inception of OpenAI's GPT series. The unveiling of generative pre-trained transformer models by OpenAI revolutionized text generation capabilities. Each iteration, from GPT-222 to the robust GPT-3, showcased leaps in understanding and producing coherent, contextually relevant content. Rise of deepfake technology. Although controversial, deepfake technology demonstrated the power of GenAI in altering visual and audio content convincingly, sparking discussions about its ethical implications and potential uses. Emergence of art creation by AI. AI systems like DALL-E and Midjourney began embracing creative domains traditionally dominated by humans, generating original art pieces and showcasing GenAI's creative potential. These milestones highlight the incredible journey of generative AI, illustrating not only technological achievements, but also preparing us for the complex landscape of opportunities and challenges that lie ahead. As we transition into understanding these challenges and ethical considerations, we find a poignant reminder of the nuanced ecosystem that GenAI operates within. As we traverse through the vast landscape of generative AI's evolution, it's crucial to pause and deliberate on the challenges and ethical considerations that accompany this transformative technology. While the milestones we've achieved illuminate the path forward, they also cast shadows of potential pitfalls and dilemmas. Here are some key points to ponder. Data privacy and ownership of generative AI systems heavily depend on massive data sets for training. This raises concerns about the privacy ownership of this data. How do we ensure that the individual's data is used ethically, and what mechanisms are in place for them to maintain control over their personal information? Bias and fairness. AI models learn from the data fed into them. If these data sets carry inherent biases, there is a significant risk. How can developers ensure that the systems they build promote fairness and equality, accountability, as AI systems begin to operate with increasing autonomy? Determining accountability for their actions becomes complex. In cases of misuse or error, identifying responsible parties, whether the developers, users, or the AI itself, is not always straightforward. Malicious use. The capabilities of AI systems can be harnessed for both good and ill. Safeguards must be implemented to prevent the deployment of AI in harmful contexts, such as generating deepfakes or automated cyber attacks. While addressing these challenges is no small feat, dialogue around them is essential as we progress. The evolution of generative AI isn't solely a technical journey. It's equally a societal one, necessitating a concerted effort from technologists, ethicists, policymakers, and the public. This conversation is crucial as we look towards the future, envisioning how these technologies will unfold and redefine our world. As we gradually unpack the myriad possibilities that generative AI offers, it's fascinating to observe its current applications, which are already transforming numerous industries. From dazzling the arts to optimizing the mundane, the scope of generative AI is both broad and profound. Art and design, generative AI is revolutionizing the creative sphere. Artists and designers are using these models to generate new forms of art, tailor personalization in fashion and even recreate the styles of renowned painters. Music and entertainment. AI is rapidly becoming a tool for musicians, assisting in composing melodies or even creating entire symphonies, offering fresh avenues for collaboration and creation. Content creation. Writers and publishers are leveraging AI to compose content faster and more efficiently. AI-driven chatbots and virtual assistants are becoming standard in customer service and digital marketing, manufacturing and product design. Generative AI is involved in designing new products, optimizing supply chains, and even in computer-aided design work, enhancing efficiency and sparking innovation. Healthcare, by generating synthetic datasets, AI is aiding in drug discovery, creating personalized medicine options, and predicting patient outcomes, promising a healthier future. As technology continues to evolve, so too does the pot as technology control for generative AI. Future prospects hint at further integration into more fields such as education, law, and finance. Imagine AI crafting tailored educational experiences or analyzing complex legal scenarios with remarkable speed. Generative AI, with all its potential, stands as a testament to human ingenuity and the power of technological advancement. As we look to the future, the innovations and applications we witness today are merely a preview of the transformative changes to come. In continuing to explore its capabilities, we must remain mindful of the challenge ahead, especially when it comes to seamlessly integrating this technology into society in a responsive and ethical manner. As we delve into the evolution of generative AI, it's clear that the journey from its nascent stage to its current state has been nothing short of transformative. What began with rudimentary models capable of generating simple outputs has now blossomed into a sophisticated array of technologies driving innovation across numerous sectors. The transition from early AI models to today's sophisticated systems highlights certain pivotal developments in the field. Increased computational power. Progress in hardware capabilities has enabled more complex AI models, advanced algorithms. Innovations in algorithms have significantly enhanced the efficiency and capability of our systems. Data accessibility. The proliferation of data sources has allowed for more comprehensive training datasets, improving model accuracy, integration of AI ethics. An ongoing dialogue about ethical practices ensures responsible AI development. The ongoing evolution of generative AI doesn't conclude here. Instead, it sets a foundation for continuous advancements. As researchers and developers push the boundaries, we anticipate breakthroughs in human operation, future systems designed to work in tandem with humans, enhancing creative processes. Real-time adaptability. Generative AI models that adapt instantaneously to new information and environments. New models of creativity, entirely novel forms of art and music generated by AI reshaping cultural landscape. As we reflect back and look forward, the evolution of generative AI is not just a story of technological progress, but also of how we as society adapt and integrate these innovations into our lives. The conversation doesn't end here. It is just beginning as we collectively envision what the next chapter of generative AI will bring.